Alright, we're going to talk about the linear equations, and mainly we're going to talk about them in slope-intercept form. When we talk about slope-intercept form, we have two main things we're talking about there. So we're talking about our slope, which is m, and we're talking about our y-intercept, which is b. So when we see this, our m is the slope, and our b is the y-intercept, or that point where our line is going to intersect with the y-axis. Let me see if I can change this a little bit here. Alright, so if we're given something where we're given the slope and we're given the y-intercept, that's probably the easiest case where we can actually write our slope-intercept form. In this problem, our slope, it's saying, is -2, and our y-intercept is 5. So if we use this formula up here again, y equals mx plus b. If we write our formula, it's really easy. We want to write y is equal to m, which it's telling us in the problem is -2. And then we're always going to multiply our slope by x. So the rate of which x is changing, we're going to multiply by x. And then we're going to add in our y-intercept, which is 5. So our equation here with a slope of -2 and a y-intercept of 5 would be y equals -2x plus 5. And now just for review, that graph would look like this. From left to right, it's going down, and it would cross our y-intercept at 0, 5. If we look at our second one, where we have a slope of 3/4 and a y-intercept of -3, again, we're going to use the same exact formula, except we're going to change out our slope. So this one, our m is equal to 3/4, so we'll say we've got 3/4 x, y-intercept is -3, so we're going to say our slope-intercept form is equal to y equals 3/4 x minus 3. So really, like I said, that's going to be the best case scenario where we have the slope, we have the y-intercept, and it's actually pretty easy to set up our equation. Now, there's going to be times when it's not that simple, where we're given a graph, and we've got to write the slope-intercept form given the graph. So now, when we're talking about slope, we're talking about rise over run. So we're talking from two different points. So I have a point, So I have a point here, and I have a point here, and I'm talking about the rise over run between them. So I'm talking about the rise, which is my y, over the run, which is my change of x. So if I look at this, my rise in this problem is going to be 1, 2, 3, 4. So it's going to be up 4. So it's going to rise 4. And it's going to go over 1, 2, 3. So over 3. So my slope is going to be 4/3. That's a 3. Is 4/3. My y-intercept now, if I get my eraser out, get rid of these a little bit. My y-intercept, like we just said, is going to be the point where our line crosses the y-axis, which is going to be right here. So I can see my y-intercept is going to be -5. Now my equation, like we did before, equation's pretty simple. Once we have the slope and the y-intercept, my equation is going to be y equals m, which in this case is 4/3. So it's going to be 4/3 x. Since my y-intercept was in -5, it's going to be -5. Okay, so simple enough. To find my slope from the graph, I do rise over run. I find the slope. I can look and see the y-intercept. Then I can write the equation. Number 4, if we look at it, we'll do the y-intercept first because it's easier to see. Where do these two lines intersect? So I'm talking about the line and the y-axis. They intersect at the point 0, +1. So +1 is going to be my y-intercept. Now I've got to find from left to right what the change is between them. So I'm going to draw this little triangle here, and I want to see what is my rise over my run. So in this case now we're falling 1, 2. If we're falling, we're going down. We're account for that by putting a negative. So down 2. My run 1, 2, 3, 4. I've got negative 2 over 4. Now anytime we have something like this in math, we like to reduce, put it into simplest form. So I'm going to call that negative 1/2, or negative 1 over 2. So I've got my slope, which is m, and I've got my y-intercept, which we should see as b. Only thing I have left to do now is write my equation. If I write my equation, it'll be y equals mx plus b. So m, we said, was negative 1/2 times x, and b is a positive 1. So that's how I write my equations. Given a graph, I can find the slope, and then I can find the y-intercept. Alright, the last thing that we'll be doing, at least for right now, is we're going to be finding the slope given 2 points. So remember, if I have these, if I have these 2 points, so 2, negative 1, we'll say it looks like that, and 10, negative 13 looks something like that. I have these 2 points. I'm trying to find what the slope of this line would look like. So I'm trying to find the rise over run without having to count anything. And I can do that by using this formula here. First thing I got to do is label my points. So in my point 1, which is 2, negative 1, the x is 2, so I'm going to label that as x1. That's my x there. And the negative 1 is my y, so I'm going to call that y1. On my second point, which is 10, I have my x of 2, and I have my y 2. So I can see now where these variables are actually coming from. y2 is the y coordinate of the second point, y1 is the y coordinate of the first point. x2 is the x coordinate of the second point, x1 is the x coordinate of the first point. So now all I'm going to do to find the slope, I'm going to plug this into my equation. y2 is negative 13. And I'm going to subtract that from y1, which is negative 1. x2 is 10. x1 is 2. If I subtract these, negative 13 minus negative 1 is going to give me a negative 12. 10 divided by, or 10 minus 2 would be a positive 8. Again, anytime we're talking in math, we want to reduce. Negative 12 eighths, if I divide both those by 4, is going to give me negative 3 over 2. Negative 3 over 2. So it'll be down 3 over 2. I can do the same thing over here, and we'll do another example for the second one. I've got my x1 and my y1. And I have my x2 and I have my y2. So I'm going to put it into this formula. I got my m equals y2, which is 6, minus y1, which is 3, dividing that by x2, which is 4, minus x1, which is negative 5. 6 minus 3 gives me a 3. 4 minus negative 5 gives me a 9. If I reduce that, I've got 1 over 3. So now we can see there's strategies that we can find our slope, and we can find our slope-intercept form, both when we are given a slope and a y-intercept, when we are given a graph, and when we are given 2 different points.